D2DNY, Real World HVAC Simplified. And now, in this video, what to expect as a commercial HVAC mechanic. So if you're an HVAC mechanic and you do commercial work or commercial services, what to expect, all right? So here you have a condensing unit. This is a commercial type, obviously, and it's very old. There's a VFD drive right there. VFD drive, which is supposed to control your condenser fan motor. Okay, but it's all shot, it's all burnt out. This is a commercial situation, so I'll be replacing this drive, right? And I'm going to be putting, I've already have some of the components ripped out. I'm going to show you what I ripped out, but this drive basically was used to control the condenser fan motor. Okay, and based on, you know, pressures, they will ramp up and ramp down. Okay, so this is an old unit, so the drive is shot. It's a lot of money to replace it. So what I'm going to be doing here today is replacing the drive with this bad boy. This is a contactor and motor overload protector combination. Actually, it's not a combination. Let me set this down over here. I don't want to drop it because it's very expensive. Rather expensive, not very expensive, but this right here, you're looking at about $1,200, right? Probably between $800 and $1,200. Okay, so this piece right here is the overload section, overload. That comes separate. I joined them together. All right. This piece right here, you can pop it off. So on this one out of the box, this hand right here looks just like this hand right here, exactly identical. There was a connecting screw wire terminal block attached to the back of it. I think I've done a video before where I'd shown something similar, but this piece you can pop right off. So I'd pop this part off of the overload on this end, and so that I could join it with the contactor. Combined together is what we call a starter. All right, so there you go. So again, this is a day, I guess part of the day in the life of an HVAC mechanic who works on commercial stuff. All right, so this is what you're going to expect to do. If you have not done these things before, you have not seen stuff like this before, this is a commercial world. All right, by the way, I'm on a roof in New York City. Oh, that building is really tall. Look at that. I'm actually on the 48th floor, I think, or 50th floor. The roof, 58th floor. And that building, look how many storage, our floors remains. That's a skyscraper. Wow. All right, so enough of that. Here are some of the components that I had ripped out. You know, and I'm saying I'm going to toss these all in the garbage. I've already got these ripped out. So this is what I was talking about for the on the overload. You see, on the overload, this part right here, as I was pointing out, you can take off. You can pop this off. Okay. And let's get into the condenser section. This is an old mammoth unit. I could get this thing open. There you go. Oh, this is a 30 horsepower motor, baby. 30 horsepower with a centrifugal blower. Wait a second. Get some light on this. This is dark in there. Okay. Centrifugal blower, right? You don't see that in residential stuff. Right? Centrifugal blower. Centrifugal, baby. You don't see that in a residential, only in commercial. This is a 30 horsepower motor. Whereas the horsepower as a voltage, kilowatts, HP, right there, 30 horsepower. All right, and it's dual voltage. It's 460 and 208. So that's commercial HVAC service. Okay, centrifugal fan. And the way I'm turning this wheel right now, that's the true rotation, the proper rotation. This is not the proper rotation this way. That's wrong. That's the wrong rotation, right? This is the way it goes. That's the proper rotation. Right? So yeah, belts, three belts. Okay, let's go around to the condenser coil section. Beautiful winter day in New York City. So to give you an example of how tall the building I was pointing out earlier is, you can see how high up I am, right? And if I'm this high and I have to look all the way up to see the other building, that's the top of a building over there, right? You know, so it's crazy. That building is crazy tall. This is where I'm at right now. Like literally, I'm like 50 story up, 50 floors up. So that building is super tall. It's probably like 100 plus floors. Okay. But yeah, it's a day in the life, you know, HVAC, mechanic, does commercial stuff. Sometimes you are in a situation like this, you're on the roof. Here's the evaporator section where they got the compressors and everything. There's another VFD drive in here, or the evap fan. That VFD is working. There's your controller and everything. So I'm going to tell you the plan for this in a little bit, like the plan for making the condenser fan motor works with only the contactor slash starter. I'll tell you the plan in a minute. This here looks like you got 4 circuits, right? I see 4 side glasses. Yeah, so they're definitely 4 circuits. 4 compressors. But 4 compressors, I think probably they're in tandem, I don't know, or maybe the coils are back to back, because when I look in here, it appears to be only 2 coils, right? But actually no, I stand corrected because it's 2 coils. See, 1 coil in the bottom, and it kind of like merges right there, and another coil up top. I'm gonna get some light in there. Light in there. So that's the part of the fan. Alright, so yeah, it's actually 4 circuits, and you can tell because each coil, so it's 2 coils, but each coil holds 2 circuits. So here's a liquid line right here, there's a discharge line, and there's another discharge, and oh, wait a second, how did they do this? It's a bit weird how they got this going. But all in all, they got 4 circuits in here. Because you got 2, this is 1 pair, discharge and liquid, discharge and liquid, discharge and liquid, and there's 1 more somewhere. Oh, another 1 down here. So 1, 2, so it's 1 right here, 2 right here, 3 right here, 4 right here. All right, seems like they piped it a bit. I don't know, this 2 goes together, this one and this one, it's 1 circuit, and then this one and this one, that's another circuit, and then this one and this one right here, another circuit, and then the two up top. But that's the condenser coil. Condenser coil. See the louvers right here for the front. And commercial HVAC is my toolbox. So I'm gonna talk to you real quick of the plan that I'm gonna do for this right here. I don't want to drop this because it's rather expensive. So the coil voltage in this contactor right here is 110 volts, 120 volts. So here's all the billing I was talking about. I want to show you guys again. It's crazy. That building is mad tall. But anyways, back to work. So yeah, this is 120 volts coil. Here's your coil terminals. There's one right here, and the other one right here. Just gonna sit this right here because I don't want it to fall. So this, I have no schematic, by the way, as you can see, no drawing. But I figure this relay is labeled here as condenser fan, right? You probably can't see it, but I cleaned it off and I was able to see it says condenser fan, right? So then this relay, the coil gets energized via a switch on the evaporator or air handler or the other half of the unit. It's a split unit with remote condensers, right? So this is a remote condenser because only the coil and the fan. So you know, these two wires here is the switch, right? I traced it out already, and it takes 24 volts off of this transformer right here, and this gray wire is already I zoomed in a little bit. Okay, this gray wire already goes to the common side of the transformer, 24 volts, and so this other yellow wire needs the 24 volts hot, or is 24 volts hot, which is going to come over here on the other side of the relay coil right here. Now this is one side of the coil that goes to the 24 volts common. This right here, other side of the coil, it needs 24 volts hot, and I found that this wire right here brings the 24 volts hot because it, from one side of this transformer, the 24 volt side, you can see the wire, I pull on the wire, it goes, you can see it goes right here, same wire, pull on it, it goes right here, and it goes to the air handler unit, right? And this wire right here is a two wire, red and black, right? Red and black brings one goes into the switch, comes back out of the switch, comes back through this other wire. See, this one right here, I got disconnected. It brings the 24 volts back and goes into this relay. So with that said, that's pretty much, you know, the control section. So what I'm going to be doing, whenever the air handler calls for this relay to turn on, which is labeled condenser fan, I'm going to take this power from this relay and I'm going to put it on this relay, rib relay. All right, this is like advanced stuff. This is actually advanced stuff. You know, if you're do it yourself, for this video is like entertainment for you, because you won't have a clue. If you're a beginner, you'll learn something here. If you're a pro, you might know this stuff already, but you know, you can also learn something. So yeah, so this right here, I'm going to take 24 volts. The 24 volts that powers this relay is now going to power this relay. So I'm going to connect white with yellow and white with blue. One here on this gray wire. I'm going to take this gray wire out completely and splice it right there, and then the other one is going to go here. So whenever the air handler enables the condenser fan, guess when more than likely that's when you're calling for cooling. I'll test it to find out. This is all in the works. I haven't tested it yet, but I think when it calls for cooling, when it needs cooling, it's going to enable the relay, enable the condenser fan relay, which is this relay right here. It's going to be now this relay right here, right? It's going to be changed to this, and then this is going to be enabling the drive, making the drive ready to run. And there's another set of wires which I don't care about right now, because I'm not going to be using that. These wires here will be bringing the signal, the reference signal to tell the VFD drive how fast to run. I don't care about those other wires because I'm not using the VFD anymore. I'm just using the starter. So yeah, that's pretty straightforward. Got questions about it, leave it in the comments. Oh, if you haven't subscribed, subscribe right now. Subscribe right now. Hit that bell icon so you get videos like this when I do them right away, notified right away, instantaneously. Okay, what else? Yeah, oh, so this relay right here, you got so that's for the coil section. I'm gonna use 24 volts. This is multiple voltage. You can do common, you can do white with yellow, and then you can put, if you got 120 volts, that's powering to power this relay. You can use white with black and white with yellow, and that's 120 volts powering the relay. You got 24 volts, common right here, use this one, and then you use this one, power the relay. And here's your common. It's pretty much, this is a single pole double throw switch, SPDT, single pole double throw. And so I'm going to be using, on here, I'm going to be using the orange, and I'm going to be using the yellow, right? I'm using normally open, common, and normally open, all right? And so whenever the switch over here closes, or switch over there closes, this will get 24 volts, power up, this light will turn on. When that happens, it's going to close between, the connection is going to be closed between common and normally open, which is yellow and orange here in this case. See the colors? Or RG for orange, and yellow, YEL for yellow. Okay? So when that happens, I was going to close, and then what I'm going to do, this, because this the contactor coil on this is 120 volts, so I'm going to have one side of here, my coil going straight to 120 volts neutral, which is this transformer right here. That takes the 460 volts that comes in. See that color? Brown, orange, yellow. Be careful, 460 volts. And it converts it down to 120. So I'm gonna take the common side, or my neutral side of my 120, go on one side of my contactor right here. And then the line side, I'm gonna pass it through my yellow and orange. So I'm gonna go yellow on one side of the 120, and then the orange will come back over here. But I'm also going to put a wire from here to the normally closed auxiliary switch on the overload, because I want, if this thing trips, disable the contactor, right? And I don't want the fan to keep going, or the contactor to be activated still. If this thing tripped, I don't think it really matters, but I'm just gonna wire it anyways, because if it tripped, then it's gonna break the three-phase power that comes in right here. It's gonna break it, so there's no power over here. But perhaps I won't do it. I don't know. I don't know. I'll probably do it anyways. Just wire the coil voltage or the coil power through the auxiliary switch over here. Maybe I'll do it. Maybe I won't do it. I don't know. And here's where you dial in the settings for the motor, the amperage draw. This particular motor, and the nameplate, it was 35.5 amps. So I'll just move this dial and make it point at move this dial, rotate it. You can adjust it, make it point to 35 amps. Open this little clip right here, the little glass right here, you can open it. I don't want this thing to fall, but you can see what I'm talking about. The little glass protection over it, you gotta pop it open. There you go. So I got it open right there. Oh crap. It's open now. And then you use your screwdriver and turn the dial. Again, go to look at your nameplate of the motor and see the full load amp for 460 volts, because you're going to be a full load amp for 208 volts because it's dual voltage motor. So it's wired up right now for 460. So the full load amp for 460 in this case is 35.5. So I'll move this dial to 35. Or maybe I'll gauge what is currently running right now with my clamp on, amp it on over here, or on the wires once I'm done. And then I'll set the over amp or the protection amp or the trip amp. You know, probably I go 5 amps above. I don't know. But you see what I'm going with this. If you're a commercial or mechanic, HVAC mechanic, you know, you're pretty much familiar with this stuff. You got questions about it, leave it in the comment section, I'll answer it. Again, subscribe, hit that bell icon. Okay, enough for the talking, I'm gonna get back to working. And once I'm done with it, I'm testing it, I'm gonna come back. Stay tuned. Now, one thing I want to point out before I install this baby, this bad boy right here, is that you see these right here, this is actually a DIN rail mountable component right here, and I have a video on that. I might leave the link in the description, but this is a DIN rail mountable. But you see how I pull out the what is done right here, pull these parts out, pieces out, so you can use the screws and mount it. Yeah, these you can slide out, you slide in and out, push them back in, all right, and you can just slide them out in the back, pull them out and mount it with the screws, regular screws, if you're not using DIN rails. And then on this part you can pull it out as well, and you gotta, it latches. I got one hand right here, let me pull it out, I'll get back, hold on, stay tuned. So there it goes, it's out, sits in place. There's a latch, that little lever right here. If you push down on it, if you push down on this little lever, this piece will slide back in. Okay, because like this is spring, that part is spring loaded. That's how it gets clipped onto the DIN rail if you're using that option. All right, like I said, I had joined these two, I had married these two, the contactor with the overload. Subscribe right now and hit that bell icon, because you're gonna get stuff like this all the time. Okay, stay tuned for the finished testing when it's gonna be like right there. It's gonna be installed right there, like this way, like right there, like augmented reality right there, augmentation. So I'm gonna install it. Stay tuned. Okay guys, so there is the finished product. Got my starter and my relay all wired up, ready for testing. Now remember, just dropped my tool. I hate that, but no one got hurt. Totally safe. So what I was gonna say, yeah, so remember on this relay, the wire with the white with the stripe, white with stripe, are blue, white with blue stripe, white with yellow stripe. These are the coil. Okay, these are the coil. These are the control part of the relay, a control section of the relay. I would say, and then the solid colors, those are your contacts, right? Those is what you're going to use to, you know, turn on your device. For example, this starter right here. Okay, so again, the one that has this white with blue stripe, black stripe, white with blue stripe, white with yellow stripe, and you can see them right here. There's one. Am I getting that? Okay. One right here, and there's another one right there. Okay, those are your 3 coil, relay coil. So I'm using 24 volts right now, so I'm pretty much ready to go. I'm just gonna move this up a little bit, this dial. These have 35 amps on my thing, so I'm gonna go a little bit below just to be safe. It's gonna go like 32 amps, right? All right, so I'm gonna leave it like that for now. I did wire in the auxiliary. I wired in, so when this relay turns on, it's going to take 120. There's right here is 120 volts hot, right here, this terminal. Goes right through, go through the relay, come over here. If this is actually on, then it will pass through, come back around, and go into the coil of the contactor. See? So again, from here it goes orange wire. And, you know, the orange wire is this wire right here. When it closes, it's going to pass through the yellow wire, which is this yellow wire right here at the bottom, and it's going to come around, go up. This is closed because if this is on and not tripped, then this is going to be closed. The auxiliary is going to be closed. Passes through this red wire right here. I roll it underneath, come around, and go to the our coil right here. And then the other side of the coil, 120 volts neutral or common, goes right here into this this side right here. See the gray wire? Okay, so that's pretty much it. Now I'm gonna be bypassing the switch. So I got one wire. I got my little stick on. It's magnetic. So I'm gonna be bypassing the switch in the air handler, simulating that, you know, where cooling is enabled and we're running cooling. Okay. And then let's see what happens. For the first time, we're gonna start up. Actually, not the first time. I tested it already. Psych. Let's go. All right, so my relay is turning on, but why isn't my motor starting? I hear nothing. It's quiet still. All right, so that's because I wire it through the auxiliary, and it's currently off. So let's remove this. All right, I don't want to touch ground with this. I don't want to touch it to the ground because then that might be a problem. All right, so then we're going to put this on. All right, so it's on, and let's go now. Second time is a charm. Here she goes. I can smell the rubber burning. The belts. Slippage, I guess. Oh. I think the door is open in here. I heard it just slam closed. Yeah, this was open. Woo. So we're getting a lot of suction back here. Yeah, so she's running. Just as a test, you know, I simulated it. So when the system is calling for cooling, that switch that I had bypassed, that I shunt with my jumpers, should be closed by the air handler. We got water bubbling out here. Look at that. That's crazy. That is crazy, guys. Like, super crazy. Yeah, we got 29 amps. Take this. Oh man, this is 460 volts. Right here. I can check right here. Same difference. 28, 27. So I could adjust the trip current on the overload down a little bit, right? So I can make it, I think 30 amps is fine. I can leave it at 30 amps. I'm gonna leave it where it's at, 32 amps. Okay? Yeah, if you like this video, give it a thumbs up. Alright? If you haven't subscribed, let me get some lights over here so you can see. So again, I'm shunting or bypassing the switch from the air handler. That switch is supposed to be closed when you're calling for cooling. That's what was activating this condenser fan relay. Okay, but I removed it and wired it this way. Starter is controlling the fan. The only thing is that I don't know if it's going to be like always enabled once the cooling is on, even though the compressor has not been called for. I don't know. I guess the test will see when I put the cooling on from the air handler over there. And yeah, that's pretty much it for this video, guys. If I go ahead and I remove it, open the switch, you can hear my starter contactor disengaged right away, and the rev relay is deactivated. Now let's go look at the motor, how it's spinning. So this is just the inertia, and you can see which direction it's turning up, which is the right or correct rotation of this centrifugal fan. That's the way they rotate. You know, unlike looking at it from this angle, the way the scoops are set, you might think it's supposed to be going the opposite way, but if you're looking from the inside, the scoop is actually grabbing the air where it throws it out over here. So on the inside, it's actually angled towards where the airflow, where it's going to grab the air from the inside and throw it out over here. And this, don't try this at home, because if your fingers get caught like in between the belts and the wheel, you're screwed. It's going to cut right off. All right. So you can see that this way. Typically, you would say, well, it should be going this way, right? Because it's going to scoop the air. But when it goes this way, because on the inside of the wheel, on the inside, that's where it's going to scoop the air from. This is where it spits it out, on this side. It comes out on this side, and on the inside, in the middle, on the inside, from over there, all right, from the other side, it sucks in. So the scoop is actually angled that way from the other side, from the other side. So that's pretty much it for this video, guys. Again, if you like it, give it a thumbs up. If you haven't subscribed, subscribe. I do videos on a weekly basis. Don't forget to hit that notification icon, or the notification bell. And I'm gonna give you one more view of the city. New York City, baby. New York City. So, it's New Jersey over there. If you're still here, you're special. So, you get a view of the city. There's that crazy tall building. Oh, look at that. Wow. There's a part of it.